Okay. Oh, number one, we've done about a zillion of these, so you're really good at this, I'm sure. What are you going to do with the sine of 5 pi over 3? Okay, you can change that to degrees, and how many degrees would that be, Mr. Muehlman?
300.
And that is exactly right. Does anybody have a question about how we got 300? He said we're going to find the sine of 300 degrees. Okay, so we'll draw our handy-dandy circle, right? And 300 degrees will be down here. How big will that reference angle be right there inside the triangle? That'll be 60. Very good. We are getting really good at those. That's a 60-degree angle, so you can label the sides of your triangle, right? All right, so what would those be if this is 60? This would be root 3, that would be 1, that would be 2. Right? Anything negative? Root 3 is negative. So we have x equal 1, y equal negative root 3, and r equals 2. Remember, this is a coordinate plane, so anything horizontal is x, anything vertical is y. So what's my answer? Negative square root of 3 over 2. Perfect. Got it? All right, number 2. Ooh, we haven't done one of these in a while. Anybody remember the basic formula? S is the letter they use for arc length. Anybody remember the basic formula here? What?
Radius times radian.
Exactly. Thank you. Arc length is radius times radians. Very good, Mr. Orr. Radius times radians. So when I look at the first one, it says the radius is 8.
Oh, Miss Ford, I forgot. Extra credit.
The angle is, not for you, maybe for Reed or for remembering that, 4 pi over 9, and I wanted to know the arc length. This could not be easier. You have everything you need, don't you? So what's the arc length? Radius times radians, 32 pi over 9. Was there a unit on the radius? No. But if there had been, if that radius had been, let's say, 8 inches, then the arc length would have been in inches. The unit on the arc is going to measure or match the unit on the radius. Okay? That one was easy. I have a feeling the next one is not so easy, but let's see. Oh, no, it is. It is just as easy. The radius is 10, the arc length is 18, and we want to know the angle. What's our formula say? Arc length equals radius times radians. So what's the measure of the angle? 9/5. And what's the unit on that? Radians. That's 9/5 radians. Let's diverge for just a second and do one that might be a little bit harder. Just so we're able, in case you get thrown this curveball. Let's say you have this situation. The angle is 50 degrees, the arc is 10 inches, and we want to know the radius. Now, what do you have to be careful about here? You need to switch the degrees to radians. If you're going to use that formula, and that is such an easy formula, I would recommend it. If you're going to use that formula, then your angle has got to be in radians. Right, Harry?
Yep. Yep.
Okay. So we need to change 50 degrees into radians. Anybody remember how to do that? Very good, Delaney. Pi over 180 equals? X over 50. Perfect. We know pi radians is 180 degrees. We want to know how many radians is 50 degrees. So it looks like that's going to turn out to be, when I reduce it, 5 pi over 18. So my angle, instead of thinking about it as 50, I'm going to think about it as 5 pi over 18. It's the same thing, it's just a different unit now. Now can I use my formula? So 10 equals, arc length equals radius, which is r, times radians, which is 5 pi over 18. So I'm going to multiply by 18, so I have 180 equals r times 5 pi. And then I'll divide, so r equals 180 over 5 pi. 180 over 5, 36 over pi. And what will be the unit on that? Whoa, whoa, that's a radius. That's a radius. What's the unit on the radius? Inches, just like the arc. Don't think just because you see a pi, it's a radian measure. You can have pi in anything. Okay. All right, we need to erase all this. Everybody okay with that? What's our formula for arc length? Radius times radians. Very, very easy. If your angle's not in radians, get it in radians by solving the little proportion Delaney reminded us about. Okay? All right, 1.5 radians. How many degrees? Any ideas? Maggie, were you pointing at this? Because if you were, you were right. This is the idea we want to use. Now, obviously, it's a little bit different scenario, but that's exactly the idea we want to use. Okay, so what's that proportion going to look like? Pi is to 180. That never, ever changes. 1.5 over x. How's come it's 1.5 over x and not x over 1.5? It's radians over degrees. If you say pi over 180, then you're going to say 1.5 radians over how many degrees? So pi x equals, what, is that 270? So x equals 270 over pi degrees. Number 4, we just talked about a couple days ago, so maybe that's fresh in your mind. Find a positive and a negative coterminal angle for 230. What would be a positive coterminal angle for 230? 590. How did we do that? Add 360, very good. Okay, what about a negative coterminal angle? Negative 130, and how did we get that? Subtracted 360. How do we get positive and negative coterminal angles? We add and subtract 360. If we're in degrees. If we happen to be in radians, then we would add and subtract 2 pi. Right? Tangent of pi. Okay, what do you think about that one? What about the tangent of pi? Well, yeah, think of that as tangent of 180, sure. What do we do with 180? It's on the line. We call that a quadrantal angle. It's on an axis. So we still need to know x, y, and r, people. How in the world are we going to figure out x, y, and r?
We pick r.
We're going to make it up, yeah. So we'll pick r. We'll let r be 1. So then what would this point be? If the radius is 1, that point would be negative 1, 0. So x is negative 1 and y is 0. Tangent. Y over x. Y over x will be 0 over negative 1, which is 0. Perfect. oh my, cosine, 183 pi over 4. You do not have a calculator. You are on your own here. That's a mighty big angle, would you agree? Let's change that to a mixed number and see how much we can get rid of. 183 divided by 4, what is that as a mixed number? 45 3/4. Did I divide right? 45 3/4. So think about 45 3/4 pi. How much of that can be just gotten rid of, just ignored? 44 pi. Because what does 44 pi represent? 22 revolutions. Remember, a revolution is 2 pi. So we can get rid of every 2 pi. It can just be gone. So since there's 44 of them in there, 44 pi's, we'll just get rid of all that. And we're going to end up with the cosine of 1 3/4 pi. Now, when we've seen that before, it hasn't looked like 1 3/4, it's looked like 7/4. I don't care which way you write it, it's totally irrelevant. How many degrees is that? We need to figure out how many degrees that is. So, pi is 180, divided by 4 is 45, times 7 is 315. So that's the cosine of 315 degrees. Okay. Where's 315? Fourth quadrant. What's the reference angle for 315? 45? Okay, so 1 root 2. Anything negative? The y1, yeah, that guy is negative. So x is 1, y is negative 1, and r is root 2. And what was I looking for? Cosine? Cosine is 1 over root 2 or root 2 over 2. Does that look okay to everybody? Good. Very good. Okay, number 7. Ooh, this is kind of like what you did in last night's homework. Which, by the way, we're going to look at next. Find the values of the 6 trig functions if the tangent is negative 3/4 and the sine is negative. Got to figure out where to draw this triangle. Tangent's negative. What does that narrow it down? Gives me a couple of options if the tangent is negative. 2 and 4. So I'm either going to look in quadrant 2 or I'm going to look in quadrant 4. Tangent is a negative number. Tangent is y over x. The only way that can be negative is if either x or y, one of them's positive and one of them's negative, right? Okay, now what? Narrow it down even more. Sine is negative. Where's the sine negative? What's sine associated with which coordinate? Y. Where's y negative? Down here, right? So this was not the answer. This is where I'm looking now, right here. This is the only place that the tangent is negative and the sine is negative. So I'm going to label my triangle. What am I going to put where? Look right here. What am I going to put where? Negative 3 is the y. And x is 4. Is everybody okay with that? And if I do the Pythagorean theorem, that works out to be 5. Now what was I supposed to be finding? All 6 functions. So I need sine, cosine, and tangent, which tangent was given. And cosecant, and secant, and cotangent, which is also given. You gotta love these problems. You have a third credit. You haven't even done anything. Now we can fill in all the rest. So what's the sign? Negative 3/5, which means the cosecant is negative 5/3. What's my cosine? 4/5, which means my secant is 5/4. Any question about that? Harry?
Yes.
You know, someone walked in, like some administrator, walked in and saw you sitting there with your eyes shut. I would get like in trouble for that.
Well, I've been paying attention.
I bet you have. Okay, let's look at number 8. Solve triangle ABC. Who remembers what that means? Haven't talked about that in a couple days. What does it mean when we say solve triangle ABC? Find everything that we don't already have. And everybody remember the way we label this in case, this one's already labeled, but in case it's not labeled for you, you remember that across from angle B is side B? Big letter, capital letters for angles, small letters for sides. So we need to find angle A. That's a no-brainer. We can do that. What's the measure of angle A?
28.
28. We know that's 28 because the angles of a triangle have to add up to 180. Now we pick a side. It makes absolutely no difference which side you do first. Anna, which side you want to do first?
B.
Okay. I want to find B first. All right. So how you propose we do that?
Well, can you do the cosine or?
You can do cosine if you use 28.
Okay.
You can say, if you use 28, you could say cosine 28 equals 5 over b. Does that make sense to you?
Yeah.
You couldn't use cosine if you were using 62, but it's okay with 28. So b cosine 28 equals 5, and b equals 5 over cosine 28. So we can just type that in our calculator, and I'll warn you again, what do you have to be careful of anytime you're putting trigonometry into your calculator?
Radians.
Yeah, are you in the right mode? I was not, so I'm glad I checked that. 5 divided by cosine 28. I got 5.663. Anybody match that?
No.
Now, some of you might be thinking, oh, I'll just use the Pythagorean theorem now. I would rather you didn't because that's a rounded off answer. Is there a better way we can find side A without using a rounded off answer? Tangent 28 would equal A over 5. Now, groupies, is that the only way to find side A? No, you get to pick. There are tons of ways you can find side A. Is that a fine way to find side A? Absolutely. So A equals 5 tan 28. So we should be able to find that one. 2.659. Everybody okay with that? Okay, if we have time, I want to come back and we'll practice some more if we have time. If not, because tomorrow's our quiz, remember. If not, maybe you can practice on your own. Let's look at homework now. We do have a couple of things we do, so I need to keep an eye on the clock. But we can do a couple of homework questions. Anybody have one? Homework question? Maggie?
39.
39 says 7 pi. I want to find the sine, cosine, and tangent of 7 pi. Okay, where's 7 pi, Maggie? Okay, I don't even care about that. It probably is. I don't know. I'll trust you on that. 7 pi is more than a revolution. So I'm just going to take out all the extra stuff. So how much can I take out of that? I can take out 6 pi. That's 3 revolutions. So really, I'm going to be finding the cosine of pi, because I'm going to take out all those extra revolutions. That's the cosine of 180. Well, we had 180 up here earlier. This is 180 right here. So if I know x is -1, y is 0, and r is 1, I can find cosine, tangent, all those things. Does that make sense to you? Okay. Okay, anybody else have a homework question? One of the problems in the homework gave you, and this could be last night's too, because it was all on the same page. 60? Okay, did you estimate for January, April, June, October, and December? Did you do those? It says estimate the number of get wet swimsuits sold in January, April, June, October, and December. Did you do all those? Because 2 of them are supposed to be the same, but I don't know which 2 of them are doing it.
It's June and December.
June and December turned out to be the same. Did and how did you find, let's say June? How did you find the June number?
We put 7 in for T.
Let's see, January, February, March, April, May, June. 6 in for T.
Yeah.
And then you just type on your calculator, and that is a radian measure, so we got to make sure we're in radians. Okay, so I'll do June. So it's 72.4 plus 61.7 sine pi times 6. Oh, divided by 6. Oh, I put that in there. So I got 72.4. Is that what you got, Delaney, for June?
Yep.
Okay, so that was June's. And you said you got exactly the same thing for December. Okay, now, can you think of a reason why that might be? I mean, just in terms of real life problems. Forget the math. We can explain it mathematically. It's going to be tough at this point for you to do it. But what? Okay, and why would they, I mean, think about buying a bathing suit. So like June, what's June?
Summer.
June's the beginning of summer, so a lot of people are buying bathing suits at that point, right? What's December? Christmas time, people going on vacation, buying Christmas gifts, getting ready for, trips in the winter, winter break or whatever. So practically speaking, that would be a reason. Now, mathematically speaking, there's a reason, and that's a great lead-in to today's lesson. Remember that everything I talk about from this moment forth, new stuff anyway, is not on the quiz, is not on the exam, will not be assessed until after Christmas.
This was gonna be
What?
Is this gonna be like similar to the stuff we've been doing?
Oh, yeah. Yeah, we're just going to start graphing now. So we're going to go back and we're going to talk about the answer to the swimsuit problem mathematically. But right now, let's review, what does a sine curve look like?
Goes through the origin.
Goes through the origin. So you remember that this is what your sine curve looks like. Now, gang, it actually goes on forever and ever in both directions. Okay? It goes on forever and ever in both directions, up and down and up and down. We don't need to graph all of that. Because every hill and every valley looks just like every other hill and every other valley. The sine is what we call a periodic function. And what it means to be periodic is it just keeps repeating itself. The chunk that repeats itself is called the period. Now, what repeats itself? One hill and one valley. Because what happens after you draw a hill and a valley? You draw another hill and valley, and so on. So this piece of the sine curve is called a period of the curve, and it's adequate. You don't need to draw any more. That's it. When someone says to you, draw a sine curve, you can get by with one hill and one valley. So that's all we're going to draw. Now notice that the hills have height and the valleys have depth. You can figure out the maximum and minimum values probably without too much difficulty. Anybody have an idea how tall these hills and valleys are for a regular sine curve, just a regular old sine curve? 1. Now, can anybody think mathematically why that's the case? Why are you saying that?
Because there's nothing to like, if it would have been +1, if it was 1, you're good.
Okay, so you remember from when we graphed these before, we were at 1 and -1. Can you explain why it is we're at 1 and -1? I mean, we are, and we're going to memorize that, but can you explain it mathematically? What's the definition of the sine? SOHCAHTOA. Just use the SOHCAHTOA definition. Opposite over hypotenuse. And I want you to think about a triangle. And I want you to think about the ratio of the opposite to the hypotenuse. Will that ratio ever be more than 1? How come it can't be more than 1? Because the hypotenuse is always bigger, right? So there's no way that fraction can ever be more than 1. What about cosine? In a minute we're going to do cosine. Could we say the same thing about cosine? Yes. That height is called the amplitude. The amplitude of a standard sine curve is 1. Now we can change that by putting numbers into the problem like Maggie was talking about, but the standard sine curve has an amplitude of 1. By definition, amplitude is half the distance from the top to the bottom. You can think about it as the height of the wave or the depth of the valley. That's the amplitude. Amplitude is always positive because it's half the distance or it's a height, always positive, and we can adjust it. We'll do that in a second. So the verticalness of the curve, the up and downness, is kind of gauged by amplitude. The horizontal, the length of the curve, is gauged by period. This distance is 1 period. Remember, a period is the repeating chunk, and for a sine curve, that's 1 hill and 1 valley. Now I want you to think about, we've already talked about it many times even today. Every time you do this, you just start over again, don't you? Every time you go around the circle. So what is this period, do you think? How far is it from here to here? 2 pi. Because what happens after you go around the circle? You start repeating yourself and repeating yourself. Think about those big problems we did earlier. We just threw out the extra 2 pi's, right? Because they don't change anything. The period of the sine curve is 2 pi. Which means that this label would be what? Everything here is symmetric, so this label would be 1 pi. And what would this label be? Pi over 2 or 1/2 pi? And what would this label be? 3 pi over 2 or 3/2 pi? 1.5 pi, however you want to write it. That's what your sine curve looks like. Now, what do you think would happen if we put a 2 out in front? Now stop, think way back to August. What happens when we put a 2 out there? What does it do? It changes the height. It's a multiplier. It multiplies the height. This number is going to multiply your amplitude. So if I ask you to sketch this sine curve, you're going to draw exactly the same picture you just drew, only it's going to be 2 times as tall. Nothing else is going to change. It's just going to be 2 times as tall. So we would say here that our amplitude is 2 and our period is still 2 pi. Period, remember, is this way, and we haven't done anything to change that. Putting a number out in front multiplies your amplitude. Okay, okay. What about this one? What's the negative going to do? Turn it upside down. Exactly. So now you're going to have your valley first and then your hill. How tall is it going to be? 1/2. These are not going to change because you haven't done anything to your period. You haven't affected the horizontal, you've only affected the vertical. So we would say our amplitude is 1/2 and our period is still 2 pi. Notice my amplitude is 1/2, not negative 1/2. The negative turned it upside down, but the amplitude is still 1/2. The height of the waves is still 1/2. Okay. Hang on to your hats.
Just where am I wearing it?
No extra credit for you. All right, here we go. Now, we know what the 3 does, right? We've just done a couple of examples. We know the 3 is going to make our sine curve 3 times as tall. What does that 2 do? Notice where it is. It's hooked to the x. When you hook it to the x, it affects this, right? What does it do to it? This is the tricky part. Think back. It actually divides it. This number divides the period. I don't know if you remember or not, but way back when we talked about all this and we did things, back then we weren't using a sine curve, we were using some funky shape that I would draw. Remember, I would draw some shape, you know, like this, and I would say, okay, now let's sketch 2f3 of x, something like this. And we talked about that number multiplies the vertical. So for a sine curve, that's the amplitude number. This number divides the horizontal. Okay? Mackenzie? So, what is our normal period? Where's our normal ending spot? 2 pi. Everything's getting squished. So now where is this one going to end? This one's going to end at pi because your period is 2 pi divided by 2 or pi. The period of every sine curve starts out as 2 pi. If you put a number here, it's 2 pi divided by that number every time for a sine curve and a cosine curve. Now, that's going to change up the rest of the labels too. What would this be? Remember, we're evenly spaced here, so this would be half pi, wouldn't it? What would this one be? 1/4 pi. And what would this one be? That's a half and a whole. What's halfway between a half and a whole? 3/4. There you go. So your amplitude was 3 and your period was pi.
I just have a question about that one actually. So is it always going to go up on like the right side, like after the origin? Do you know what I mean? Like when you flip it, like is it, if it's positive, is it always going to be like that one, and when you flip it, is it always going to start going under?
Yes, yes. A positive sine curve goes up, or has a hill first. A negative sine curve will always have a valley first. Yeah. All right, let's try one more, and then we're going to move to cosine, but that's nothing to panic about because it's exactly like the sine. Let's do this one. Let's do negative 2/3 sine 1/3 x. Okay, lots to keep track of here. Slow it down, one step at a time. First thing your beady little eyes might notice is it's a negative. So that tells me, Michael was just talking about it, that tells me I'm going to go down first. Everybody okay with that? How far down? What are these labels going to be? 2/3 and negative 2/3. So my amplitude is 2/3. Got it. Remember what Maggie said before about moving it around? I don't know if you heard her. She was talking about something. She said you could pick it up and move it around. We haven't done that yet. Do you remember how to do that? What would you have in the equation if you were going to move this thing, pick it up and move it? You'd have pluses or minuses somewhere. We're going to do that, but not today. All right, now what about my period? What is this number going to do? That number right there is going to do what? It's going to stretch it. My period, which is supposed to be 2 pi, has been divided by 1/3. So what is my new period? 6 pi. That means that from finger to finger is 6 pi. So this label is 6 pi. We have been stretched 3 times as long. What's this label then? How about this one? 1.5. I like fractions, so I'll say 3/2, but it's 1.5. How about this one? 4.5. I'll say 9/2, but you can say 4.5. There's nothing wrong with that. Now, everything we just did applies 100% to the cosine. The only thing that's different is the curve itself, right? I mean, how you position the curve. Do you remember what a cosine looks like? Just a regular old general cosine. It starts here. It has the same hills and valleys, exactly the same hills and valleys, but it starts at the peak. Now, when you draw a cosine, if you're going to start at 0, this is 0, then one period of the cosine has this sort of odd shape. That would be one period of the cosine. It is still a hill and a valley, but because of its position relative to the y-axis, the hill has been cut in half. So you got half the hill at the beginning and half the hill at the end. But the amplitude is still 1, and the period is still 2 pi. It's the same curve, just shifted. So this label would be pi, halfway between. Here's your pi over 2, and here's your 3 pi over 2. Just exactly like the sine curve. Just shift it over. So if I asked you to sketch this, could you do it? I think so. First of all, it's a positive cosine curve. Starts up here, ends up here. What's its amplitude? How am I going to label these points here? 4, -4, yeah, the amplitude is 4. Remember, this number multiplies the amplitude. The standard amplitude is 1, so when you put a 4 out in front, it's going to be 4. Now, have we changed the period this time? Yes, we have. What have we done to our period? We've divided it by a half, or multiplied it by 2, which means that we end at 4 pi, which means our minimum value, the low point here, happens at 2 pi, and our zeros, our x-intercepts, happen at pi and 3 pi. Pretty easy. We'll do one more and then I'll stop. We'll do a -1, a negative cosine. How about negative cosine? Any idea what that looks like? We're gonna flip this, right? So it's going to start actually down here and do this. What's the amplitude? 2. I wonder about my period this time.
1/3.
The period is supposed to be 2 pi, but it's been divided by 6. So now my period is pi over 3. That means it's really been squished. You can't tell it on my graph, but it's really squished up. All right, here we go with fractions. What's right in the middle? Pi divided by 6. Very good. What's right in the middle of that? Pi divided by 12. Very good. Now this one's a little tricky, but not if you think about it like this. Remember, everything's evenly spaced. So pi over 12, this would be 2/12. This is 1/12. Wouldn't this be 2/12? What do you think this is then? 3/12 or 1/4. And then that is 4/12. Everything's evenly spaced, so you can just count your way down the line if you want to. Also, I am not going to get hung up if you don't reduce these. We're going to run into so many fractions. If they're not reduced, it doesn't bother me one bit. Okay. All right. Well, tomorrow we have a quiz, as you know. We have practiced the last few days, so it shouldn't be a big deal to you. But I did notice that there are a couple of more practice things in the packet. There is no sketching on your quiz, but there are at least 2 more quizzes that have some extra practice for you. And tell you what I'll do. I see the very next page in my packet is another practice sheet. It says Precal Practice 4143 number 2. I will work out those answers. I did not give you the answers, I don't think. I will work those out and hang them outside the door. So if you want to do them and check them, you can. We have a meeting before school tomorrow, so I will be in here, but I can hang them things out there. Oh, wait, Katie's gotten a new one done, did? Oh, good. Are you Anna Maria? Okay. Full-size non-generic box tomorrow. And what was your question, Anna?